Hello friends and welcome back to Purus Tech Java tutorials. So in this session we are going to cover about the autoboxing and unboxing feature of Java and one more topic, that is the generics. So what is autoboxing and what is unboxing? Let's see. So the basic definition of autoboxing is if you are converting your primitive data types to its corresponding wrapper classes, then it is called autoboxing. So let's take one example. If I'm converting this integer primitive data type to its corresponding wrapper class, that is integer, then it is called the autoboxing, right? And if I'm doing the reverse one, that is the other way, is called the unboxing. That means converting from integer to int primitive data type, then it is called the unboxing. So this conversion is applied to all other primitive data types. So here are the primitive data types which are available in Java, and these are the corresponding wrapper classes. So let's go ahead and see some examples. So here I have written auto boxing and unboxing example. Let's put the main method. What we'll do, we'll just declare one int type of variable, int amount equal to 19, let's say, right? And let's declare one method, public void display amount. Here I will just say integer, so it takes an integer argument amount and it just displays the amount. So the amount is, here I can write the amount is amount, right? And I can call here this particular method by just creating an object of this class autoboxing unboxing example equal to, use the new operator to create the object, and then call this particular method display amount by passing this primitive data type. So here I'll just pass amount. So what happens here? So I'm just passing a primitive data type, that is int here, but this particular method takes a wrapper type. So internally this is being converted, the primitive type is converted to a wrapper class type. So this is the autoboxing example. Let's try to run this program. See here the output. Let's take one more method which does the reverse one, public void display count. Then it takes some primitive data type, let's say count, and here I'm just writing sysout, the count is, then count. So here I can write in the command auto boxing example, and here the unboxing. Let's see how to use this one. I'll just declare one wrapper type integer count equal to 20, let's say, and let's try to reuse this object. I just will call this display count method here dot display count, and I will pass the count variable here. So count is of wrapper data type, but I'm holding this count variable here in this actual method, right? The parameter is of primitive data type. So what is happening? So the wrapper class is converted into a primitive data type, and this is called the unboxing. Let's try to run this. See here, the output has come. And likewise, you can pass any other primitive data type or any other wrapper classes like this, and you can use wherever you want to use it. Let's go further. So we have just covered the autoboxing and unboxing examples. Now let's come to the generics. So before going to these words, right, what is generics and all, what is the advantage and all these things, let's try to see what is exactly generic means in our code. Then we'll come to the advantage, so that we'll understand by code, not by this theoretical concept. So this theoretical concepts we will cover after the code walkthrough. So here I have written a class that is without generics example, and this particular class will use for explanation of generics. Let's say I have one more class which is the number holder, and which I'm going to use this particular class inside our without generics example. So let's create a main method here, and let's create the object of this number holder. So this number holder will contain the integer data type equal to new number holder, and I wanted to print what integer number it is holding. So what I can do here is I can put one setter and getter method. Setter and getter method is nothing but the method which sets the value is called setter method, and which get the value is called getter method. Now let's see how to generate the setter and getter in this IDE. So just right click here, and you would see generate, and here you would see setter and getter. Just click on this one, and for which variable you are going to generate the setter and getter. So you just click whatever variable you want. Here I have only one variable, so one it is showing. If you have multiple variables, so this will be having multiple variables. Just say OK. So it will generate these two methods. So I just wanted to set the number to some value. Number holder dot set number as 10, and then I just wanted to print what number I have set into this particular variable. So I'll just use sysout the number set is number holder dot, you can use the get number method. Let's try to run this program and see. As you can see, the output, whatever we have set the number before, we are getting that number and printing that number. Now for example, if I want to set some double value, what I can do, I have to change this to double, let's say, right? And I have to change all these things to make it compatible with this double. For example, I just have to delete this, and I need to again generate the setter and getter, and click on the double variable. It will give us the getter and setter method, and you can set some double value to this and you can print it. Let's run. As you can see here, it is printing 10.9, which I have set. Now for example, I just wanted to reutilize this particular class to hold any kind of number. Let's say float, let's say double, let's say integer. So how do I do that? I can make use of object, which is a super class of all the classes defined in our JDK, and whatever you are going to create in your program or application, all will be the subclass of the object class. So as we have seen, the superclass reference can hold a subclass object, right? So using that particular feature, I can hold a integer value, I can hold a double value, I can hold a float value, anything into this one. So let me just try to generate the setter and getter here for this. As you can see here, this particular example still works with this particular object. And if we just run this program, it will print 10.9. Okay, how do I set a integer number? Just remove this, and still this program works and it will print 10. So I can hold a double value as well as an integer value in my program. Now let's say, so here what I wanted to get is some addition value. Let's say I will define object addition value equal to number holder dot get number plus 2, let's say. As you can see here, this particular operation get number plus 2, it is giving me compilation error because this plus operator cannot be used on an object. So what we need to do is we need to convert this particular object to a integer. So how to convert that one? You need to cast it. So there is something called casting. One is upcasting, one is downcasting, right? When the superclass is converted to a subclass, that is called the downcasting. So here the superclass is object and the subclass is integer type. Let's say for example I am taking the integer value, so subclass is integer. Now I need to downcast this object to a integer type. How to downcast? Just here you need to write integer. So there is a parenthesis start and parenthesis end, and then you can use this get method so that this particular object can be converted to a integer type by using this particular casting. Now you can use this plus operator on this casting value, and here I can convert directly this to integer. Now let's take this output above to this addition expression, and let's put one more sys out for this addition value. So the addition, let's put integer addition, right? Integer addition value is, then just utilize this particular variable here, and then let's run this. As you can see here, this integer number 10 plus 2, the result output is 12. So let's create one more object which will hold the double value here, double number holder, and I will say double number holder dot set number, let's say 20.2. Let's add some integer value to this particular double value like this expression. We'll keep it here and just change this variable name double addition value equal to, we need to change this one to double number holder dot get number. So this double number holder dot get number will return 20.2 and here it will add 2 to this 20.2. So here let me just convert this to double and here also double value. Let's take this printout statement and utilize for this double addition value. Now let's see whether this program works for both integer as well as double or not. Let's run. As you can see here, both integer and the double value is perfectly working fine. In this program, there is some serious issue which may occur during the runtime. So let's see what error it might come during the runtime. Let's say instead of 10, by mistake somebody passes some other value. Let's say some string value I will pass. Okay. The compiler is not able to identify what is the error, but when we will run this, we'll come to know. As you can see here, one exception came. So exception is an unwanted event that occurs at the runtime. This is altogether a different session. So we will cover the exception in a different session. Now let's come back here and see what exactly happened. At the line number 10, it is saying line number 10, and in this particular class file, there is issue. So let's click here. So in this line number 10, what is happening? This particular method is returning on string since we have set this hello string here. And this hello string cannot be converted to integer since this is hello. Hello cannot be converted to integer. That is why this exception is coming. Now, how to overcome this particular situation? So we can apply the generics. Let's come to the advantage of generics now. See here, generics add the stability to your code by making more of your bugs detectable at the compile time. Since at the runtime we are getting this, would not be it is easier if we had find out this particular issue at the compile time? Yes, perfectly. We can do that by using generics. Let's see how we can apply generics in this particular program. Now let's take this particular example, just copy and paste in this generic example. So I will utilize this generics example to illustrate how we can apply the generics. So let me just remove this and make it similar to this file name. Double package is there, just remove. And let's rename this to generic number holder. So this is just a naming, and by making this name as generic, it doesn't mean that we are converting this particular class as a generic. So to apply generic, what we can do, we can make this particular class as a generic class. So how we can convert this class into a generic type? We need to pass a generic type parameter. So basically this type will be checked at the compile time. Let's see how to do. Here you need to put type parameter here like T, your angle bracket starts, angle bracket ends, and your type. And this type you can utilize here. So let's utilize this. Make this as a small t and let's generate setter and getter for this. Now this particular class has become a generic type. So in the compile time, we need to specify what kind of parameter it takes. So here, instead of this number holder, I need to just reutilize this generic number holder. So in this generic number holder class, what kind of parameter I need? For this section, I need integer type, and for this, I need a double type. So here, during the object creation, you need to define like this, what kind of parameter it takes. So it is taking integer type. Now, this method has changed, so I will just use set t method, and here if I will pass string, it is giving me the compilation error. See here. So at the compile time, it is checking the type of parameter which we have defined here in this line number 5, that it is expecting an integer type. So we cannot pass any other type during your compilation time. So the compiler checks strictly this parameter, what kind it is and what kind of parameter we have declared. So we need to pass here as integer only. So now it is not giving me any issue. Here I need to say dot get t, get type in the sense, and here also I need to just use get t, and here the second point covers, the second point is elimination of casting. So this casting we don't need to take care of, we can delete this now. As you can see, no problem found in this particular statement. Now let's convert this section to generic type. So I need to use the generic number holder here, generic number holder, and I take double type parameter, and I have to use dot set t, and then here get t. We don't require any casting here. So as you can see, this has been converted to a generic type, and we can run this program to see what happens. It should work fine for both integer type and for the double type. See here. So this is what this two statement means. And the third one, this third one we will cover in the next session, because there are some other generic concepts are also there. So we will cover other rest of the generic section in the next class, along with this explanation of generic algorithm. So till then, stay tuned and thanks for watching this video.